Okay, making a video here on stars, answering the questions, what are stars, how are all stars the same, and what makes all stars different. I again am joined by the fabulous Nicholas Lee. You might know him from Grease
What?
the Musical.
Best musical ever.
Okay, we'll see. Okay, starting with stars. Nick, what's a star?
A huge ball of gas.
Now, what kind of gas are we talking about?
Hydrogen and helium.
Mostly hydrogen and helium, right? Which is there more of?
There's more of hydrogen.
All right, there's more hydrogen than there is helium, okay? What do all stars do, Nick?
They shine.
That's what stars do, okay? Think about how important our stars' shine is, you know, how important our stars' sunlight is. What do we get from our stars' energy?
Basically light and heat.
Light and heat, and how is that light and heat important?
Because it helps us with our everyday experience and stuff.
Okay, would we have food without the sun's light?
Nope.
We would not. We wouldn't have a food chain. Would we have a water cycle?
No.
No. Okay, so that's really how stars are all similar. They're all kind of made up of the same stuff, and they're all the same shape. They're all spherical. How are stars different, Nick?
By their temperature, size, color, and brightness, or luminosity.
Or
Magnitude.
there's another word we can use for brightness called magnitude. Basically, all three of them we'll use for brightness. Okay, so you're looking at different stars here. Nick, which one is most closely resembles our star?
The yellow one.
This one or this one?
I think
It's a toss-up. That one looks
Yeah.
right to me, but this one's not too far off. We're a little yellow-orange. So here we have stars of different size. We have stars of different color. Now, Nick, if you see stars of different color, what do you know about them?
that mainly about how the color represents also the temperature of the star.
That is correct, okay? Of the ones on the screen, which one do you think is the hottest?
The blue one.
All right, blue is the hottest. Think of a flame on a stove. A blue flame on a stove is hotter than a yellow flame from a candle. So color will relate to the temperature. Blue are the hottest, and then which is the coolest star?
The red one.
Yeah, there's this red one. That's going to be a cooler temperature than this blue one. Okay? Okay, what makes a star shine? We talked about how important our star's energy is, but what makes a star a star?
By the nuclear fusion inside of it.
Nuclear fusion. My students know this to be my favorite F word, fusion. Okay? What is fusion?
It's basically when two elements are basically kind of like the two elements of same mostly are combined together by lots of heat and pressure and a whole lot of it.
Okay, inside of a star, you're right. It's a very high pressure, very high temperature. Now, this is a little bit fancier than the way we talked about it in class. This is deuterium and tritium. I want you to ignore that. Nick, how many protons are drawn there?
There are two.
One here and
Oh,
one here, right?
yeah.
So they're both what element?
They are hydrogen.
They're both hydrogen. They're showing you guys heavier isotopes of hydrogen. Let's keep things very simple. Nick, what is hydrogen's atomic number?
1.
Atomic number 1, right? And that 1 means 1 proton, okay? So when you have inside of a star, it's very hot. Nick, how do atoms behave when it's hot?
They float around really, really rapidly far apart.
They move around a lot. They move around very fast. So when inside of a star, when you take two hydrogen atoms, they fuse together and collide with a lot of speed and a lot of force. This is really, really important. Okay, that creates a lot of energy released, and then you end up with an
Helium.
atom of what?
Helium.
Helium, right? So two hydrogens make a helium. Basically 1 plus 1 equals 2. But what's more important is the energy that's given off, okay? What do we call the energy from our sun?
Radiation.
Radiation, we can call it solar energy, we can call it light, we can call it heat. The important thing is that my marker's going out of batteries. The important thing is the energy,
Yeah.
okay? Hydrogen fuses to helium, and that gives us lots of energy. That energy is very important. So this happens inside of all stars.
Yes, it does.
Okay, but it takes a while for a star to actually mature and start its fusion process. We're talking now about the life cycle of a star. Okay, think of the life cycle of a person. Everybody's born the same way. Okay, everybody got here the same way. Everyone's born as a baby, they mature into a teenager and then a adult, and then what happens after you're an adult?
You turn into an old person and die.
You grow old and eventually you die. Stars do the same thing. The cool thing is if you're a star, once you're dead, you can kind of almost be reborn. What are all stars born out of, Nick?
A nebula.
All right, a nebula. Define nebula.
A huge cloud of interstellar gas and dust.
What does interstellar mean?
Basically inside stars.
Not inside of
Well,
stars, but in between
in
stars.
between.
Inter means in between, and stellar means star. So you have huge clouds of gas and dust. They're very, 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 very cold, and they have a low density. Now, what happens to these nebula?
That they turn into a protostar by gas and stuff, and the gravity starts sucking more and more of it up together, and
Okay.
it'll press together.
We take this big, spread out nebula, and basically we crush it, okay? So eventually, the star will be what shape?
A sphere.
Sphere. But before that, when it's a protostar, we kind of have...
Like a sphere with discs.
Yeah, we kind of have the ball forming in the middle, but kind of leftover disc-shaped outside of that. Again, it's getting crushed by gravity. Okay, I had to pause there to make sure I'm recording. Sorry about that. It's getting crushed by gravity, and as it's getting crushed, what happens to the temperature?
It starts to rise.
Okay, it starts to increase, right? Eventually, that temperature rises enough, and then what happens?
It goes to a it comes together, fuses, and goes to a main sequence.
All right, once the temperature reaches that magic number, fusion begins, the star starts to begin fuel, it becomes a main sequence. Okay? Now, so far, the process is the same, whether you're a high-mass star or an average star. Okay, what are we?
An average star.
We're an average star. This is the low and medium. So far, the process is the same. Nebula, protostar, main sequence. Now, after that, you have a different life cycle for the two stars, or for the two types of stars, based on mass. So, let's focus on our star first, an average star. Eventually, you run out of fuel, right? What's a star's fuel?
Hydrogen and helium.
Hydrogen fuses into helium, so eventually all the hydrogen will run out and you're only left with helium, okay? Once that force of fusion starts to lose the battle against gravity, gravity starts to win, right? And it's going to crush the inside of the star. As the inside's getting crushed, it's going to get hotter, and the helium will start to fuse into...
Iron, carbon, stuff like
Maybe not iron, but it can fuse all the way up to carbon, okay?
Yeah.
It can fuse heavier elements. Can a low-mass star fuse carbon?
No.
It can't, right? So it's going to have a core of carbon that builds up, and gravity's going to start to crush it, and start to crush its core. What's going to happen to the outside of it?
Starts to expand.
Starts to expand, and that takes us to our
Red giant.
red giant phase. So the inside of the core, the star is getting crushed, the outside starts to grow. Eventually, the core basically loses control of the outside, and that's called a
Planetary nebula.
planetary nebula. That nebula takes us back to where we started. Okay, stars recycle. The inside of the core is left over, and that's called a what?
White dwarf.
That's called the white dwarf. So what will our sun eventually end its life as?
A white dwarf.
A white dwarf, okay? That's the last step in the process for small stars, for small and average stars like our sun, okay? Now, the big stars go through a similar process, but they have more mass, so they'll have more gravity, higher pressures. They can fuse in their giant and supergiant phase. They can fuse up to what element?
Iron.
They can fuse from hydrogen all the way up to iron.
That's pretty big.
All right, that's the heaviest element. They can't fuse iron, so an iron core starts to build up inside the star and become unstable. What happens when it becomes unstable?
Goes into a supernova
All right, what's a supernova?
when it explodes, basically.
When it explodes. Is that the last step?
Nope.
Not the last step. After that, you have two options. You're either a neutron star or you are a
Black hole.
A black hole. Okay, the black hole is reserved for the absolute biggest of the biggest stars. Okay? The neutron star is kind of like the white dwarf. It's a leftover crushed core. The neutron star is even smaller, has even more mass. It's very, very, very high density. But these are your three possible deaths. Only one way you can be born, but three possible ways to die.
I'm glad our sun's not going to become a black hole.
Yeah, but when it becomes a red giant, we're pretty much in trouble either way.
Yeah.
I don't think there's... Ooh, there is more. All right, Nick, what's that?
That is a HR diagram.
What's an HR diagram good for?
It describes the temperature and brightness of stars.
Okay, temperature and brightness of stars. It's just like in math class an XY graph, right? Nick, what's the only exception here that might be different for people?
Except for on the x-axis, instead of going up, you're actually going downward.
Okay, so when we increase towards the left. All right? Your y-axis is normal. Your y-axis is brightness or luminosity or magnitude. That one increases as you go up. But the x-axis down here is a little fishy. It increases going backwards. So as you leave the origin, it decreases. Okay, you'll notice in HR diagrams there's a kind of path that goes down the diagonal of the HR diagram. What stars are those?
Main sequence.
Okay, those are the main sequence. That's an adult star acting like a star. Okay, so let's cover the compass first. We covered something in class that might help with the HR diagram. As you go up the graph, the stars get
Brighter.
brighter. As you go down, they get
Dimmer.
dim. To the left, they get
Colder. Hotter.
hotter. They get hotter to the left. That's what's different. And to the right, they get
Lower.
lower temperature. They get cooler, right? So where are the hottest, brightest stars?
They are the top left.
All right, these are the hottest and brightest. So these would be the
Coldest and dimmest.
dimmest and coolest. Good. All right, so the main sequence, that's an adult star acting like a star. The biggest and brightest ones are the blue giants. Then you go to the blue-white, and then yellow, and orange, and red. So the sun is
In the middle, basically.
pretty mediocre. It's in the middle for sure. All right, now after the main sequence, a star like our sun will end up as a giant, not a supergiant, but a giant, okay? So you can see how it might cool off a little bit, but it will get,
This basically almost the same heat, but it would get brighter.
it will get brighter because it goes up in the y-axis. Okay, so the blue giants become
Supergiant.
supergiants. What happens to their temperature?
They rise. The temperatures start to cool, actually.
Yeah, as we go this way, again, they start to cool, they'll decrease in temperature, but the brightness will kind of stay the same, if not maybe even a little bit brighter. Okay, now what about these down here?
Those are white dwarfs.
All right, the white dwarfs are
Basically the death of the low or average
okay.
star.
So the sun will become a giant, and then it will become a
White dwarf.
white dwarf. Now, what about the brightness of a white dwarf?
White dwarfs aren't really that bright.
Pretty dim, right? What about temperature?
They are mainly really hot.
Okay, they're hotter. All right, so these are dim and hot. These are dim and cool. These are
Bright and
bright and cool. These are
hot and bright.
hot and bright. No, I'm not telling that joke.
Why not?
Because. All right. So that's the HR diagram. Remember remember that little compass we drew. Remember the temperature is kind of backwards on the x-axis. You should not have any trouble whatsoever. All right. And that takes us through a video about stars. Say goodbye, Nick.
Adios!
All right.